4. For Riemann tensor for the FRW spacetimes, let's use Cartan calculus to find the independent components of the Riemann and Ricci tensor in an orthonormal frame for the FRW spacetime metric equation 4-43. Solution: we have C the next equation. Thus,
C the equations equals the fraction with numerator negative a dot and denominator a w to the phi and w to the t minus cotangent x over a w to the phi and w to the x minus cotangent x over a sine x w to the phi and w to the theta. Thus,
see the following group of equations. We can use the results from the three-sphere to help now. For I, j is not equal to t, see the equation shown. The latter possible since lowering t introduces an additional negative.
Sub raised to the 4 r sub I j k script L equals sub raised to the 3 r sub I j k script L plus w sub I t and w sub j t sub a b times e sub k to the a e subscript L to the b, since w sub I t equals the fraction with numerator a dot and denominator a w sub I. See the following group of equations. This simplifies to see the equation shown. Now, for j equals t, I is not equal to t, and using a equals the fraction with numerator a double dot and denominator a minus the fraction with numerator a dot and denominator a squared.
See the following group of equations. Sub raised to the 4 r sub I t t I equals the fraction with numerator a double dot and denominator a so. See the equation shown. Consider I, j is not equal to t comp of Ricci. See the next equation. Thus, see the equation shown, and see the next equation. The Ricci scalar is thus.
See the equation shown. And we get equation 4-44. 4. 5 Riemann tensor for the Kastner spacetimes. Let's use Cartan calculus to find the independent components of the Riemann and Ricci tensor for the Kastner spacetime with metric equation 4-45. Solution: we have to start. See the following group of equations.
Thus, see the equations. For mu, nu is not equal to t, see the next equation, where the repeated indices in the last equation are not summed. For mu equals I, v equals t, see the equations. So,
see the following group of equations. To satisfy the vacuum Einstein equation, r sub mu v equals 0. R sub t equals 0 gives p sub 1 squared plus p sub 2 squared plus p sub 3 squared equals p sub 1 plus p sub 2 plus p sub 3. R sub j to the j equals 0 gives p sub 1 plus p sub 2 plus p sub 3 squared plus p sub 1 plus p sub 2 plus p sub 3 equals 2 times p sub 1 squared plus p sub 2 squared plus p sub 3 squared using 1SD equation. See the equation shown. So,
equation 4-46. 4. 6 Riemann tensor for the Mixmaster spacetime 21. If the symmetry of the three-sphere is broken by replacing delta sub ij in the previous problem by a general diagonal metric, the corresponding homogeneous spacetime is the Mixmaster universe. Equation 4-47. Where alpha and beta sub I are functions only of t and beta sub 1 plus beta sub 2 plus beta sub 3 equals 0. Find the Einstein equations for a vacuum Mixmaster universe. Solution: Mixmaster has metric. See the next equation.
Where alpha equals alpha of t, beta sub I equals beta sub I of t, beta sub 1 plus beta sub 2 plus beta sub 3 equals 0. Recall dw to the I prime 1/2 c sub j prime k prime to the I prime w to the j prime and w to the k prime, and for the adjoint rep c sub j prime k prime to the I prime equals epsilon sub j prime k prime to the I prime. So, dw to the I prime equals w to the 3 feet and w to the 2 feet and cyclic permutations for the others. Let w to the t equals dt and w to the I equals e to the alpha plus beta sub I w to the I prime. We're interested in see the equation shown.
Due to symmetries notational and otherwise, we need only consider r sub 2 gamma delta to the first and r sub t gamma delta to the first, from which we can then get the others by symmetry arguments. See the next equation, and see the equation shown. So, see the next equation. Guess.
W sub t to the first equals alpha dot plus beta dot sub 1 times W to the first times OR times W sub 3 to the first equals 1 half e to the negative alpha plus 2 beta sub 1 W squared times OR times W sub 2 to the first equals negative 1 half e to the negative alpha plus 2 beta sub 1 W cubed. Similarly, see the equation shown. So guess. W sub t squared equals alpha dot plus beta dot sub 2 times W squared, or W sub 1 squared equals 1 half e to the negative alpha plus 2 beta sub 2 W cubed, or W sub 3 squared equals negative 1 half e to the negative alpha plus 2 beta sub 2 W to the first. A consistent choice is then apparent. See the next equation. Now,
see the equation shown, where see the next equation. Thus, see the equations. And we get specifically, see the following group of equations. Similarly, see the equation shown. Thus, see the next equation. And we get, see the equations. Grouping, see the following group of equations. So,
see the equation shown. The vacuum Einstein equation is our sub-movie equals 0, so we get equation 4-48. Other applications of the Cartan method are used to solve the most complicated Riemann tensor calculations. These include CTC spacetime analysis in CH7, BH spacetime analysis in CH8, and the Arnaud-DS and Lovelock spacetimes in Book 6, 4.